Good morning, my dear students. Okay, coming to the last topic of that is what the in the module one, that is a introduction to what the interpolation model. Okay, so in this here I'm going to tell you about the concept of what you mean by interpolation model and what are the importance of interpolation model and what are the different element we are going to use in interpolation model. That is what the simplex, complex, and multiple elements. Okay, so before starting the interpolation model, so what do you mean by the basic idea of a finite element method is what it is a piecewise approximation solution. Okay, that means what the solution of the given problem is obtained by the discretization of the given body. Okay, we know that all everyone. Okay, that is what the dividing the small pieces we are going to call as what the element. Okay, by assuming the solution for each element of each element of the divided each element, we are going to do the we are going to get the by using what trial and error function of the element. Okay, the trial functions are assumed because of the displacement variation within the each element. Okay, that should all are what unknown element. Okay, so here these assumed trial functions are known as the interpolation model. Okay, so the trial whatever you are going to get the each element, that is what the displacement variation in the each element, those are unknown. Okay, so those assumed unknown trial function we are going to call as what interpolation model. Okay, so interpolation models are what these are also known as a approximation function or displacement model. Okay, so on the basis of the problem to be solved, the interpolation models what need to approximate in the given form of an either linear or non-linear. Okay, so because of this reason we are going to study about the interpolation model. Okay, so definition says what interpolation model means what. So here interpolation models are defined as it is a approximated mathematical model. Okay, or it is a trial function which will represent the displacement variation within the element we are going to call as what the interpolation model. Okay, so this is about because of this reason we need to study the interpolation model. Okay, so here definition I wrote here. So these are the defined as what it is a approximated mathematical model. Okay, or the trial function which represent the displacement variation within the element. Okay, so hence we are going to call as in this what the interpolation model. Okay, so depending upon there will be two types of interpolation model in your subject, that is what the polynomial function, second one was the trigonometric function. Okay, but present day the FEM widely use what polynomial function. Okay, which is easy as compared to this trigonometric function, so hence I have put it here darkened. We are going to use polynomial function. Okay, so what do you mean by polynomial function? Okay, so in finite element analysis we discretize the solution region to a small piece, that is the element. Okay, the polynomial chosen to interpolate the field variable over the element. Okay, we are going to call as shape function or displacement function. Okay, so because of following three reasons we are going to use what the polynomial function. Okay, so that is it is easier to perform the mathematical calculation such as a differential or integration. Okay, and it is also easier to formulate or computerize. Okay, and it is also possible to increase or improve the accuracy of the result by increasing the order of an polynomial function. Okay, these three, because of these three most reason we are going to use what polynomial function. Okay, so now let me understand also depending upon the what the classification element based on the number of nodes, types of node, polynomial used on orientation. Okay, so normally there will be two types of node. One is primary node, one more is a secondary node. Okay, primary node nothing but what only the end node. If you consider a link, okay, this is the link. If you consider only the two side, okay, two edges, the link which are present in that element, okay, such type of nodes we are going to call as what the primary node. Okay, that is a node which is present over the end side. Okay, not in intermediate. Okay, suppose if you are put load in intermediate, that is in between those two line I shown here, such type of nodes we are going to call as secondary node. Okay, so here primary nodes, secondary nodes are shown nodes through which the element connected each other to the form a mesh. Okay, that is finite element model. Okay, and the secondary node nothing but what the node introduced on the element to obtain result for the desired location but are not used to connect the adjustment of the link. Okay, so this is about the secondary nodes. Okay, polynomial for the first order, second order, third order we need to see in the detail. Okay, for first order u of x is equal to a0 plus a1x. This for polynomial functions are used for 1D element, and for the second order element we are going to use what a0 plus a1x plus a2 x square. One term is extra here for 2D element. Okay, so how depending upon the element. Okay, orientation of the element means how the element adjusts oriented within global axis other element. Okay, such type of we are going to call as what orientation element. Okay, so look at here, this is very important. So depending upon the given geometry or given problem and the order of polynomial which are going to used in a finite element model, the element, okay, in the interpolation models divided into three types, that is what simplex element, multiplex element, or complex element. Okay, so simplex, complex, multiple, or sometimes it is also called as a multiplex elements. Okay, multiple element. Okay, so here first one, let me understand for one by one. Okay, what do you mean by simplex element? Okay, the element for which the order of the assumed polynomial interpolation model, okay, consists of a constant and the linear term only are called as simplex element. Okay, that means what, the only the end link nodes should present. Okay, such type of element we are going to call as simplex element. Okay, if you consider a 2D triangle element, okay, with a 3 noded in a simplex example for the this simplex element. Okay, the following polynomial interpolation models can be used for the present what the simplex element. Okay, so for one dimensional element we are going to use u of x is equal to a naught plus a1x. Okay, a1 means only one object will be there. Okay, two dimensional means one term is extra here. Okay, that is a naught plus a1x plus a2y. Okay, so this is one term. Okay, for three dimensional element one more is extra. Okay, that is u of x comma y comma z is equal to a naught plus a1 plus x plus a2y plus a3z. Okay, so these are the polynomial functions are used to solve the simplex element problem. Okay, coming to the second one, okay, complex element. Okay, so here complex element nothing but what, so here in between node extra nodes are introduced here. Okay, such type of element we are going to call as complex element. Okay, so the element for which the assumed polynomial interpolation model consists of a quadratic, cubic or a higher order terms in addition to the constant or a linear terms are called as complex element. That means what, here the higher element number of elements are number of nodes are in the present element are more. Okay, such type of element we are going to call as complex element. Okay, so according to the need of complex element may have same shape as simplex element, but will have additional boundaries node. Okay, this is terms very important. Okay, it is similar to the simplex element, but the difference is we have to add the more number of nodes in that link or in that element. Okay, such type of element we are going to call as complex element. Okay, for the polynomial functions used for the complex element is like this. For one dimensional element, okay, so for this is the two noded element. Okay, that is three noded element. Okay, so u of x is equal to a naught plus a1x plus a2x square. For two dimensional element, same, that is u of x comma y is equal to a naught plus a1x plus a2y plus a3x square plus a4y square plus a5xy. Okay, let me understand this detail while solving the problem how we are going to get, but you have to remember only complex element nothing but what, here more number of nodes present in that element. Okay, so coming to the third one, that is what, the multiple or multiplex element. Okay, so these are those for assumed polynomial interpolation model consists of an higher order terms. Okay, so the more than complex and simplex element. Okay, but in this element boundaries are parallel to the coordinate axis to achieve their inter element continuity. Okay, for example rectangular elements. So here multiplex element means here one of the size, okay, one of the, here look at, this is a triangular element. Okay, so one of the size is parallel to the boundaries. Okay, so here longer edge is parallel and shorter edge is also parallel to the xy plane. Okay, such type of element we are going to call as multiple or multiplex element, that is normally solid element. Okay, so this is the interpolation function. T is equal, T stands for interpolation function. Okay, T is equal to a1 plus a2x plus a3y plus a4xy. Okay, we have to remember this. Okay, this equation for linear. Okay, if you understand better means same, this slide also same what I told you. Okay, complex element or higher order elements. Okay, so here or it is also called as higher order elements. Okay, so element for 1D, so look at here, so element for 1D means only the one nodes will be present, n nodes, and complex means okay, more number of nodes will be present here, and 3D means more number of nodes will be present in the solid object. Okay, so that is what the difference between simplex, complex and multiple element. Okay, so this is also same in multiple element, so one shorter edge should be parallel to this and one more longer edge should be parallel to the xy plane, that is boundaries. Okay, so by this slide we are going to understand what is the difference between simplex, complex and multiplex element. Okay, so look at here, the simplex element nothing but what, see, this is a link for one dimensional element, only the end should present nodes. Okay, this is 1 and 2, such type of element we are going to call as simplex. Okay, it is a linear one. Okay, again coming to the 2D dimensional, see, look at this is a triangle, so only the corner are present, nodes are present only the corner. Okay, so suppose if 3D diagram tetrahedron, only the corners are presented the nodes. Okay, such type of element comes under the simplex category. Okay, so coming to the complex element, okay, look at here in the complex element. Okay, so same link we are going to consider here. Here in between the element more nodes should be added. Okay, such type of element we are going to call as complex. Okay, so look at here also in simplex only corners nodes are present, but whereas here in complex in between the element we are going to add more number of nodes. Okay, these type of categories elements are comes under complex element. Okay, so coming to the multiplex also. Okay, so one multiplex means what, one end the boundary should be parallel to the xy plane. Okay, so such type of element we are going to call as multiplex element, and even a more number of nodes are introduced in between the element. So this is the difference between simplex, complex and multiple element. Okay, so this is the same the what interpolation function for simplex, complex, and multiplex. Okay, so look at, this is a simplex element, only two nodes are present. How many nodes are there? 1 and 2, 1 and 2. So here t of is equal to a naught plus a to x. Okay, like that you have to write the interpolation function. Okay, coming to the 3D, that is a simplex element, 1 2 3, three nodes are there, so one quantity is extra here, one node, two node, third node. Okay, so coming to the third, here four nodes are there, four. Okay, 1 2 3 4, one extra will be added, go on add. Okay, so like this we have to write the interpolation function. Okay, so same for the second 2D element. So here three nodes are present, here x and y plane should be there. Okay, in the 2D object. So here a1 a2 a3, one is y. Okay, so here one extra term will be there, here six term will be there, 1 2 3 4 5 6. Okay, six nodes are there, like that you have to write a 1 2 3 4 5 6. Okay, like that. This is very important, a1 plus a2x plus a3y plus a4xy. Okay, so again plus a5x square plus a6y, again it is repeated. Okay, so like that you have to write the interpolation function for the given simplex, complex, multiplex or multiple element. Okay, so this is very important for the point of examination. In examination they may ask you write a note on what the simplex, complex, and multiple element. You have to write the definitions, one example, one interpolation function. Okay, so I hope you understand the concept of interpolation model. Okay, so interpolation model, nothing but what it is, in it is a trial function which represent the displacement variation in the each element. Okay, divided each element. Okay, that is called was interpolation model. We are going to use the two types of interpolation model. So normally the polynomial function we are going to use, by using those we have the write the polynomial function for simplex, complex, and multiplex element. Like that you have to solve. Okay, so I hope you understand this concept, interpolation model or simplex, that is what simplex, complex, and multiple element. Okay, so thank you.